Hello, seventh grade. I am sorry that I cannot be there today with you for the first day of this new lesson, but I have full faith that you guys will do great. We are moving on to chapter 7. Whoop, whoop. This one is all about solving equations and inequalities. We're going to start out small. We're going to start out with ones that are one step, and then we will gradually get into two-step and so forth. So today, I would like you guys to take some notes in your math notebook. That way, if you have any questions tomorrow, you have them ready to go for me to answer them. Your learning target for today is I can solve one-step equations. There are some vocab words here. I did not print out the vocab sheet for you guys, so we can get these added when I get back. We have been working with expressions so far, so now we're going to transition into the word equation. Equation is a mathematical sentence that contains an equal sign. So this is something like 5x plus 3 equals 38. It has to have that equal sign in it in order for us to call it an equation. A solution is any value or values that make an equation true. Sometimes we might be able to do a positive or a negative for the variable, and both of those will make the statement true. When we get into inequalities, there will be like x just has to be greater than 7 to make the statement true, because the answer talks about greater than, not something that is equal to. So that is why it is value or values. We're going to start out with the singular. We're going to start out with just, there's only one answer that can make this true, and we will slowly move into the possibility of having more than one answer. If you guys are looking for additional support on this, this is on page 118 of your book. So that is where you can find some of these examples in there. So let's get started. So first, similarly to when we were working with expressions, they might give us a solution and say, does this solution work? Is this the correct answer for that variable? In that sense, we write these as a kind of a funny equation. So I'm going to do it down here. We write this as negative 2y plus 6 is equal to negative 16. That's our original equation. And then they want to know, does y equal 5? That is the question. Is 5 the solution? So when we do this, we put a little question mark above the equal sign to indicate we don't know if that's true. So when you rewrite it, you're going to do negative 2. Remember, when 2 is next to a variable, that means it's being multiplied. You're going to plug in that 5 plus 6, and then you're going to say, does that equal negative 16? Is what we're asking here. So we have negative 2 times 5, a negative times a positive is a negative. So we have negative 10. We're adding to that 6, and we're saying, does that equal negative 16? When you have a negative number, so if we're starting out at negative 10 here, we're starting out at negative 10 here, and we want to add to that. That means we're going to go to the right. 1, 2, 3, 4, 5, 6. So our answer is going to get less negatives. This would be negative 9, negative 8, negative 7, negative 6, negative 5, negative 4. So in this case, negative 4 does not equal negative 16. That's how you say this answer is not the solution. Negative 4 does not equal negative 16, and in that case, 5 is not the correct answer to this solution. Let's do that one more time just to see how that works. Oops. Okay, so determine if negative 7 is the solution to this equation. So we have 2, we're going to plug in that negative 7 for x, plus 10, and we want to know, does this equal a negative 4? Now we're just going to evaluate this equation similarly to how we did in the previous lesson when we were given a value and you just had to evaluate. So 2 times a negative 7, a positive times a negative is a negative. So we have negative 14. We are adding to that 10, and we want to know, does that equal -4. Again, I'm going to draw a number line here. If we're starting out at -14 and we are adding to it 10, that means we are going to the right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So -13, -12, -11, -10, -9, -8, -7, -6, -5, -4. So we have -4 equals -4. So -7 is the solution. Check. Yes, it is. We solved it, or we evaluated the equation to figure out that, yes, that -7 was the answer to this solution. So that's one way that we can look at solving one-step equations. The next way, we're just going to talk about what does actually solving equations mean. So solving equations, we want to isolate the variable. I'm going to show this with physical pieces tomorrow when I'm in class, or possibly on Wednesday after we get through. So the big thing that we want to talk about is the properties of equity. Oftentimes we refer to these as inverse operations, because when you are moving something from this side to the other side of the scale, you have to take the opposite of it, because there's no way to get rid of it over here unless I subtract it from there first. And if I'm subtracting it from one side of the scale, I also have to subtract it from the other side of the scale. If I'm adding it to this side of the scale, I have to add it to this side of the scale, because you don't want the scale to be out of balance. So that is what that inverse operation talks about, is that we do the opposite operation. So the opposite of adding, subtracting. The opposite of multiplying or making something larger is dividing, making it smaller. So we're going to talk about those inverse operations. And we're going to go over what those mean. But in this sense, if I'm taking 4 away from this side, I'm going to get rid of some of this other junk here that is maybe confusing. If I'm taking 4 away from this side, I also need to take 4 away from this side. So then my end would say that this variable x is equal to 7, those 7 leftover pieces. Okay, so let's take a look at how this works. So in this case, I have x plus 3 equals 0.5. So the inverse operation of addition is subtraction. We just talked about that. So we're going to start out with x plus 3 is equal to that 0.5. I took the 0 away, but if you leave it in, same answer. So we're going to do the inverse operation. So I like to talk about this as a mirror line. So we talk about this in algebra. This is how I refer to it when we get to 8th grade. That mirror line, because whatever you do in a mirror is reflected back at you. So if I do a subtraction on this side, it has to get reflected onto the other side of the mirror, so that both sides of the mirror are showing the same thing. Both sides of the scale are staying balanced. We can't have one side of the scale subtract 3, because then the other scale is going to raise up too high. So we want them to stay balanced. So we need to have a mirror do the same thing on both sides. And then you just kind of go straight down. So we have x, we didn't do anything to that, so it just stays there because there's nothing down here. Positive 3 minus 3 gets rid of it, because if I have 3 apples and then you take 3 apples from me, now I have 0 apples, so that gets rid of it. And then we have 0.5 minus 3. 0.5 minus 3 hopefully would get us to a negative 2.5. I know that many of you will use your calculator, so that will be evident on there. So then the solution to this equation is x equals negative 2.5. So x equals negative 2.5 would be the answer to this solution. It would be what the value of x has to be to make this solution work. Let's take a look at one more here. This one has, oops. Sorry, guys. Okay, this one has some variables in it. I'm going to make a space here so we can work. So the original equation is 4/5 is equal to the variable b minus 1/2. The inverse operation for subtraction is addition. So we need to add, we can draw our mirror line. Whatever we do to one side of the scale is reflected on the other side. Whatever you do to one side of the mirror gets reflected back to you on the other. So we need to add 1/2 to both sides. So we have two fractions here. Remember, when you are adding fractions, they have to have a common denominator. So we have to kind of do our own equation over here. So 4/5, I can multiply this whole equation by 2 to get 8/10. 2 times 4 is 8, 2 times 5 is 10, and half of 10 is 5/10, or we could take 1/2 and multiply that by 5. I just multiplied each fraction by the opposite fractions denominator so that I could get a common denominator, so that now I can just add straight across. When you're adding, the denominator stays and you simply add the numerator. So 8 plus 5 would get to 13/10. So in this case, we'd have 13/10 is equal to b. Remember, if you want to leave it as an improper fraction is what we call this, that's a completely acceptable answer. If you do like yours to be in a mixed number, how many 10s are there in 13? There's 1 10 in there, and then we have 3 left over. Both answers are 100% acceptable, and that would be the solution to the equation 4/5 is equal to b minus 1/2. Okay. Let's take a look at one that's not addition or subtraction to see how that works. Let's go down here. Okay, so this one is starting out 6m is equal to 27. 6m is equal to 27. So remember, when there is a coefficient next to a variable, that is the operation of, hopefully everyone said multiplication. 6 times m is equal to 27. So we have to figure out, what does m need to equal in order for 6 times it to be equal to 27? So we are going to set up our mirror line. Remember, whatever you do to one side of the equation gets reflected on the other. You have to do it on the other. We're going to do that inverse operation. So multiplication is making something larger. So the inverse of multiplying something is dividing it. So we are going to divide this side by 6 to get rid of it. You can do it like this. We've been talking about fraction bars actually mean division. Or if you like to write the division sign off to the side, both of those are completely acceptable. I'm not going to police how you show your work. But remember, whatever you do to one side, you have to do to the other. So we have to take 27 and divide it by 6. I can't harp this enough. If you want to leave it as an improper fraction like this, 100% acceptable. 27/6 can be your answer. If not, and you want to figure out how many 6s are inside that 27, there are 4 6s in there, and then we will have 3 6 left over. So if you do this, you have to simplify, because 3/6 can get simplified to 4 1/2. Or you could have done 4.5 because you did 27 divided by 6 on your calculator and it gave you 4.5. All of these answers, with the exception of this one, are 100% acceptable in this fashion. Let's take a look at one more example before I allow you guys to get going on your homework here. In this one, we're going to take a look at what it looks like to have, this one looks terrible on here, division. Okay, so our original equation is -4 is equal to y divided by 3, okay? So some number divided by 3 gives us the answer of -4. We need to figure out what that mystery number is. So we are going to draw our mirror line, because whatever you do to one side of the mirror gets reflected in the other. So a number divided by 3 gives us 4. So the opposite or the inverse operation of division is, hopefully everyone said multiplication. So remember, we don't use x for multiplication anymore, so you can either draw a dot or an asterisk or parentheses. We just really try hard not to use that x anymore for multiplication. When we are multiplying fractions, the reason this cancels out here is, remember, if you have a fraction y thirds and you are multiplying it by a whole number, that whole number is over 1. Fractions get multiplied straight across. So we have 3 times y, which is 3y. 3 times 1 is 3. Any fraction that it's a number over itself. So if I have 10 tenths, 10 divided by 10 is 1. If I have 3 thirds, 3 divided by 3 reduces to 1y. And we all know that the 1 is invisible, so you don't have to leave it there. Whatever you do to one side of the equation, you have to do to the other. Negative multiplied by a positive is a, hopefully everyone thought in their heads, negative. So 3 times a -4 is a -12, and that is equal to y. I know this seems tricky. I know this seems complicated. I am very sorry I'm not there for your first day, but I will be back tomorrow to help us wrestle with this and understand what this looks like. I do not expect you to get all of the answers 100% correct. I do expect you to try these questions and bring your questions on Tuesday for me. So today I would like you guys to do homework, page 121, oops, that's 2, numbers 1 through 21, odds. Get started on those. I will post the assignment for health in your health Google Classroom. So after you get done with your math, please check over there for your health assignment. Thank you so much, and I will see you guys on Tuesday.